Today we're going to understand dynamics, which is chapter 3 of the Cambridge International Physics syllabus. So first of all, we generally should be aware of the different kinds of forces around us. For example, the force we use to open a door, or the force of our weight on the ground. But the types of questions they ask in the exam are about the forces of friction, the magnetic force, the electric force, the forces of our weight, and the gravitational force. And we should know that the SI unit of force is newtons, which is represented by capital N. So balanced forces are when the sum of forces acting from one direction are equal to the sum of forces acting from the opposite direction. So for example, if we take this book lying on the table pushes the book upward by a force of 5 newtons, while the gravitational pull pulls the book downwards by a force of 5 newtons. These 5 newtons cancel each other out, leaving the resultant force to be 0. So we can say that the forces are balanced and the book is at rest. The same can be said about a vehicle moving at constant velocity, because the frictional force is equal to the engine force. Hence, they both cancel each other out, leaving the forces to be balanced. We can further recognize balanced forces by Newton's first law of motion, which is that an object will continue its state of rest or uniform velocity unless acted upon by some unbalanced or external force. So first of all, we can see that this ball is at rest, meaning that the weight of this ball is equal to the force that is being emitted on it by the earth, which produces no resultant force. So it confirms that it's at rest. But when we kick the ball, there's a resultant force produced, because on the left side there's a larger force and on the right side there's no opposing force to cancel it out. So the ball moves towards the left. And we can say that in this diagram, the ball isn't obeying the first law of motion anymore. Rather, it's obeying the second law of motion, which is that acceleration produced in an object is directly proportional to the resultant force acting upon it. And the acceleration will have the same direction as that of the resultant force. So while the mass is constant, force is directly proportional to acceleration, and we can be recalled of the formula force is equals to mass into acceleration. Unbalanced forces are when the sum of forces acting from one direction are unequal to the sum of forces acting from the opposite direction, which produces a resultant force. So in this game of tug of war, the left side is producing a force of 10 newtons, while on the right side, the person is producing a force of 5 newtons. When we calculate the resultant force, which is 10 minus 5, which is equals to 5 newtons, that's the resultant force, and we can see that's towards the left. Inertia is the tendency of an object to resist any change in its state of rest or uniform velocity. Inertia of the object depends upon its mass. The larger the mass, the higher will be the inertia, and vice versa. For example, if we take a large bus which has a large mass and compare it to the mass of a car, it's less. So the bus will have more inertia, hence it'll be more difficult to move or stop it compared to the car. Newton's third law of motion is that for every action, there is an equal and opposite reaction. So in the diagram, the swimmer is pushing against the wall, meaning it's exerting a force on the wall, and the wall is exerting a force on the swimmer, which is equal and opposite in direction. So the swimmer will move forward. Friction is the force that opposes the motion of an object. The direction of friction force is always opposite to the motion of the object, and it produces thermal energy. To reduce friction, we can smoothen the surface or lubricate the object with grease, etc. Friction can bring us many advantages as well as disadvantages. For example, we can safely turn our car around a corner without it skidding, or we have the ability to walk or hold a pen without it slipping. However, friction produces a lot of heat, and that heat can cause the wear and tear of moving parts in machines, especially car engines. So to learn the effects of friction on vehicles, we need to know the different kind of distances. So firstly, we have the thinking distance, which is the distance covered during the human reaction time of the driver. The braking distance is the distance covered while the brakes are applied. And the stopping distance is the total distance covered, which is basically thinking distance plus braking distance. So thinking distance is represented by a constant speed on a graph, and the braking distance is represented by the uniform deceleration on the graph. And so the total stopping distance is the area under the whole graph. So friction helps a vehicle from skidding, and there are many ways to maintain the frictional force experienced by the vehicles. So tires have grooves on their surface, which increases the friction between the road and the tire. If the tire was to be smooth, then there will be less friction, which would increase the chances of skidding. Even road surfaces are made to be rough. This increases the friction between the road and the tires. If the road is slippery, then there will be less friction and the vehicle is more likely to skid. So we can come to the conclusion that less friction can increase the braking distance, while more friction can decrease the braking distance. Friction does not affect the thinking distance because it depends on the driver's human reaction time. Next, we learn about the centripetal force, which is the force required to keep an object in its circular path. The direction of centripetal force is always towards the center of the circle, and the centripetal force is the resultant force acting on a body. So according to Newton's second law, we can say that the direction of the resultant force and acceleration is towards the center of the circle. However, the velocity of the object will always be at a right angle to the centripetal force. Centripetal force can be seen a lot in our daily lives. For example, in an atom, the electrostatic forces cause the electron to constantly revolve around the nucleus. And in the solar system, the gravitational force causes the planets to revolve around the sun. The same can be said about how the moon revolves around the earth. It's obvious that in centripetal force, a force is required for centripetal force to occur. For example, in the atom, you need an electrostatic force, or in the solar system, you need a gravitational force. And this is the end of this unit.